Okay. A hearty welcome to everyone who's joining us here live as well as on YouTube for the first of the IMSC Heritage Series lectures. So this is being organized as part of the IMSC 60 year as well as the 75th year of India's independence, the Azadi Ka Amrit Mahotsav. So the plan is to have more such lectures by scientists, with an interest in history or historians of science and so on. The idea is to get some perspectives on the kind of work that went on in India in science over the ages. So today is the very first of these lectures by Professor Govindarajan. I call upon my colleague, Professor Indumati, to introduce our speaker and to moderate the session. So people on YouTube can type in their questions on the chat box, and it will be monitored, and we'll pose them to the speaker at the end of the session.
Good afternoon, everybody. It gives me great pleasure to invite Professor T.R. Govindarajan, who is popularly known as TRG, to come and give this talk, which is a part of the ACOM series of lectures. So TRG has retired from the Institute of Mathematical Sciences. He studied at the Madras Christian College in Chennai, and for a while he was working at the Loyola College also in Chennai before he, I think, moved temporarily to Madras University and then came to IMSC Chennai, from where he retired. But I think from when I know TRG, he has visited practically, I think, every country that I know in North, South America, Europe, everywhere. So he's a great traveler. And in particular, I would like to highlight that TRG works in the area of geometrical applications to physics, to theories in physics such as black hole theories, applications in say black hole physics, which are related to the nature of the universe around us. So this relationship between geometry and the universe and gravitation is something that has fascinated him for a long time. But today's lecture is going to be on a very different topic, as you can see. He's going to talk about the history of science, uh, coming from anecdotes that he has heard and material that he has read from ancient times of India. So, Professor T.R. Govindarajan, please do not interrupt the lecture unless it's something that you absolutely want to clarify, or hold your questions for the end of the talk. We will have a question answer session at the end of the talk. And all of you, please make sure that your mobile phones are on silent or switched off altogether.
Well, thank you very much, Arjit, and also Ravindran, my great friend, Indumati, for the introduction. And well, actually, my friends asked me to. It so happened that few weeks back, about a month back, when I was here, I was mentioning something about some unknown issues in history of science, which bothered me. They became immediately interested and asked. The net result is I was forced to give a talk. So that's the way in which it happened. Most of the time, I've kept my interest in this area sort of secret, in the sense I've been writing in some popular journals, but I've never, well, I have given talks in some places, but never in IMSC. This is the first time I'm giving a talk on a topic which is not my regular line of work in physics. Okay, so this is the thing I have written in Tamil also. Sudandara Tirunal Amudha Peruvira, which is what you have called as ACAM, right? That is the thing. And the picture is Gangaikonda Solapuram. I will refer to this later at the end, which is probably some of you may become interested and visit also. Okay. Now, this kind of places are of places where I grew up, and that's why some of the questions are also fascination for these things turned up from there. Okay. The next is my disclaimer. I'm not a professional in history of science. I have collected informations, asked questions, found some answers from several sources, and this I will quote at the end. What are the sources? And I have still unanswered questions because it was not satisfactory. Whatever answers people have written, and it's unanswered. So I will quote them. And also I'm trying to collect more materials, much more than unexplored places. Okay, science in ancient and medieval India is a vast subject. I cannot do justice to this in one lecture. Well, it's more than kind of a course, 1 year course kind of thing. So I'm going to do snippets, some small bits and pieces which I have collected, which are interesting. And I also worry it can become controversial due to emotional attachments people have, that if you say something, if you do this, etc., and it may become problematic. So I just want to avoid. And I'm going to look for purely scientific questions. I'm going to focus on the science part of it and some evidences which I look for. And there are plenty. There are plenty of evidences of great work which has been done in the past. And I'm going to quote some of them, which is what my interest is. But unfortunately, this is the myths and claims about surrounding the ancient Indian science is always there for several, maybe even 100 years. People have been writing about it. Even big people have been writing. Bal Gangadhar Tilak or even Vivekananda, etc. They have been writing several pieces for which evidences are pretty shaky. But there are some interesting things. There are some claims with evidences. There are some claims which are actually evidences are there. I'm going to quote them. But unfortunately, they are exaggerated. They are great work, there is no doubt. But similar things have been there in other civilizations. So we cannot ignore that part. We cannot say that I did that first. That cannot be the thing. There are some which are unique. No doubt this was the first done in this place by somebody here. And several of them I'm going to quote. And they are really mind-boggling. In fact, they were able to do that kind of work at that time was also fascinating for me. Okay, and then there are some questions which are unanswered. I'm going to at least give a couple of examples, couple of them for which I don't know the answer, and I can confidently claim nobody knows the answer. Okay, because some people whom I know, experts, have claimed that they don't know the answer, and there are no answers available as of now. And they are really shocking. And I may not be able to cover what we gave and what we took, probably, and then probably I will try to summarize at the end. Okay, several claims have been made based on mythology. This is only one page thing which bothered me, so I'm going to mention. Of course, in the Indian Science Congress, something about the planes were flying in the earlier times, genetic knowledge, missiles, nuclear weapons, surrogate motherhood, etc., plastic surgery, medicines preventing death, bringing back youth, soul moving from body to body, and so on. In fact, Narlikar asked this question, if people had knowledge of nuclear weapons or nuclear physics at that time, well, before nuclear science is a scale we know is 10 power minus 14 centimeters. Now, before that, you have electromagnetic theory. Why is it nobody had anything about electricity or magnetism or anything at that time? People can always ask that question. There are no answers for that. So, no end to the claims in media and public domain. So, in Indian Science Congress, story like Ganesha getting an elephant head becomes a scientific achievement. Karna's birth as evidence of knowledge of modern medical practices in ancient times is quoted. Most of the time, the sources are Ramayana, Mahabharata, Vishnu Purana, Kanda Purana, etc., various things of this kind. Whenever a new development in sciences take place, for example, some work in quantum theory. In fact, recently of late, somebody was claiming that there's some work where is there objective reality in quantum theory, through quantum theory. That kind of questions, experiments were being asked. Now, whenever such questions are asked, the immediate answer is all in Vedas, everything is there. And anything we find now or anything we will find later will be there already known to great people. So this is the kind of remarks that are made. But as Jayant Narlikar, in fact, I have read his work, he has been writing many things about some of these claims. He has been writing several pieces, which I am very impressed. Has pointed out that these are more like mythological literature, written by maybe several people over a period of time. It may not be even Mahabharata, may not have been written by one person. It may be several people writing at different periods, inserting some more articles, some more things, etc. Similarly, for many of these things, they are very beautiful, no doubt. Mahabharata is a fantastic story. Ramayana is a fantastic story. It has impressed people. And we should be happy to have such brilliant stories, creative stories written at that time. And we should treat them as that. It is not only we who have this kind of mythological stories. Even Greeks had that kind of stories. Extraordinarily creative thinking at that time. There is no doubt about it. Science fiction, beating many of our current science fiction, there were a lot of things which were written at that time. So we have to be appreciative of the creativeness of the people at that time. But if we start believing those things were true, it happened, etc., without the necessary background, for example, if somebody says based on that, velocity of light was known at that time. In fact, such a question was raised to Stephen Weinberg when I was meeting him in Dublin by somebody. He said, if velocity of light measuring takes a kind of an instrument which they never had, how could it be possible? Why are you asking? So this is the kind of thing we have to face. We have to be careful about some of these things. Greeks, Romans, Persians, Chinese also had their share of myths, and they also have nationalistic and other things which are there. And there are also real people. The real people are Archimedes, Aristotle, Pythagoras, Euclid, Zeno, Al-Khwarizmi, he was actually algebra, Al-Razi, Ibn al-Haytham, he was actually founder of optics from the Arab area. In fact, we never had an expert on optics in our areas. I have never seen literature talking about it. It's not as though we never knew about reflection and other things, but we never had a great thing like optics in our midst. Okay, so there are several scholars from India like these people, Aristotle, Socrates, etc., who made important contributions to the scientific knowledge of the society. The usual claim is we gave these things, for example, some of the claims, to the world. For example, there is a claim which was made that Pythagoras Theorem was invented here. 200, 300, I will come to that. But the point is, Pythagoras Theorem was known to several other places also, and I will come explain that part of it. So there are some things which are common to all the civilizations, and we also had that kind of a knowledge at that time, and we should be happy about it. But there are some very unique things which nobody else had. We were the first Indian astronomer or mathematician or architect. We were the first to create that kind of a thing. So that makes it interesting that such people were there. Unfortunately, these contributions are, what happened is the people who are far ahead of the times by a few centuries, and they are remained only in academic circles. I could read about them only in academic books, not about in public places like popular lectures, etc., or in the media. So we need to identify them and popularize the real ones. One may be proud. If you have to be proud of your national singing, these are the people who you should be proud about. So there are some few questions for which we don't know the answer, and more work is required to be done. So this is basically the thing. So I'm going to focus on not the mythological aspects, some claims which are there, and then a couple of them as an example. And the first claim which comes to me is Pythagoras Theorem. One of the prominent person remarked, our scientists discovered the Pythagoras Theorem but gave credit to the Greeks. This is the statement made in one of the major meetings. Now the other example like discovery of zero and place value, plastic surgery and medicinal practice, I may not have enough time to go through all of them because I want to focus on what was unique to our place. So this is the thing. So what is Pythagoras Theorem? Pythagoras was around 500 BC in Samoa, Greece. He conjectured, these are all known to all the school students everywhere, that the sum of squares of right angle triangle is equal to the square of the hypotenuse. It's a simple theorem. Okay. Now it was proven by Euclid as stated in the books, etc. Now the claim is it was mentioned in Sulva Sutra few centuries before, that is 500 BC around, I think it was about 700 BC or 700 BC. It was known here in thing, and it was mentioned by Baudhyana in 800 BCE in Sulva Sutra. Now, actual statement is correct. This statement is correct. It is there in given by Baudhyana in Sulva Sutra, and it's a very beautiful book. In fact, I've read several pieces of that, and it is very interesting. And that thing is there, explicitly there. The statement that this is what is a sum of squares is equal to this is there. But we need details. Okay, what are the details? The theorem was useful for constructing. Sulva Sutra is actually meant for rules for constructing sacrificial altars and temples in areas, and people should know what are the measurements. They have to measure. Okay, and the different shapes will be there, and they have to make the same area also. The area has to be the same. So Sulva Sutra really means rules for measurement using sulva, which means a rope. It's actually a rope which is being used to measure things, and that is what was used. So if you have, what is happening is, if they wanted to make a right angle triangle, more important is 90 degrees, okay, in the construction. So if they have a something like 3 plus 4, 7 plus 5, 12 inch rope, and make it into 3 and 4 here, and then join this, they know definitely that angle is 90 degrees. So it was that kind of a thing which is being used, like our engineering students use the instruments to do these things. Altars should have very strict right angle. That angle should be exactly 90 degrees. And gods will punish, it is written there itself, gods will punish heavily the artisans if there is any violation of this rule. In fact, the first person to be sacrificed in that altar will be the same person, okay, if it is violated. So, but only thing is, there was no proof written in the Sulva Sutra. There is no proof written there. It is a statement which is there, which is very precise, correct, exactly, and very interestingly, Pythagoras also didn't give a proof. Pythagoras also stated it. In that sense, Baudhyana gave the statement before Pythagoras is a correct statement. It was known at that time, he made the thing, and very explicitly they have written down that thing. So there was no proof provided in Sulva Sutra. It was not Pythagoras who discovered the theorem, but unfortunately it is not, neither is Sulva Sutra or Baudhyana. The recorded evidence came from two places. Okay, recorded evidence came from two places. In 1800 BCE, now the records are available, Mesopotamia provided a recorded remark about the same thing. They have written down several places where such numbers and things like that will be available. And that is the first thing. I will give you one more. First proof was not due to Euclid. Euclid was the person who proved it to the extent after Pythagoras stated, etc. But this is 500 BC is Pythagoras, 300 BC is Euclid, or 400, so I don't remember exactly that time. But before that, 200 years before that, it was there in China. The proof was there in China, and I'm going to give that also. So the proof was there in China 200 years before Euclid, and explicitly, and when did the Indian proof came? The Indian proof came given by Bhaskara in 12th century. Okay, proof was given by Bhaskara in 12th century, and this is some 1,000 years before that, the Chinese proof was also there. So this is the status of the thing, and there is no doubt Sulva Sutra, Baudhyana's work on the measurement and other questions about triangles, squares, rectangles, etc., which are required for the construction activities, very brilliant, there is no doubt. But why are you stressing that this was discovered and we gave it to Greeks, etc., is sort of unnecessary claim which was being made. That's what is the real situation. Now, why is it important? The converse of the theorem was more useful for the craftsmen. Who discovered it? If you really ask me, who discovered it is what I'm going to give. The masonry work, the people who are doing the work, craftsmen, the carpenters, etc., they need to measure. And they were aware of all these things doing, and they have noted down. They have never, their knowledge was given to the children or people who are known to them, and more or less they kept it a secret, not only here in Egypt and other places also. So this knowledge which was there was being given more or less traditionally within the closed circuit or the schools which they were teaching, and that's what is the thing. And the proof essentially tried to use the converse, not the theorem itself, where right angle was very crucial. Why is it Mesopotamia? It was interesting. The rope stretchers, that is called surveyors, were asked to measure the areas for tax, a land tax. For land taxes, they were asked to do that by the pharaohs, etc., kings which were there. And every year the river will come and flood and they change the boundaries. Boundaries will be changed. So they have to do a remeasurement and find out what is the area belonging to and how much tax should be levied, etc., etc. And that is one of the reasons for this kind of thing. According to Mirananda, they are the real inventors of geometry. The geometry was by these carpenters, masons, and workers who were doing. They were the real thing who knew about what is the area, how much should be done, etc., etc. Incidentally, the meaning of geometry is geo plus metry. Geo is actually the earth, measuring the distances, etc. And that's how that word itself came from. And there are two papyri. This is the two things, Rhine papyrus and Moscow mathematical papyrus. There are the two evidences actually available. And where this evidence for these Pythagorean triples and other things are actually available. Okay, they have written down for the measurement purposes. Clear evidence that these people were aware of the Pythagorean triples in measurement. It is obvious the builders of pyramids, you remember, you should know that pyramid has a base of, the biggest one has a base of 13 acres. The base is 13 acres and it should be exactly 90 degrees. When you start here and start there, you should make sure that they meet. Okay, it's a very intricate task as you go up in this thing also as a pyramidal shape. So it was very important for them to have a clear measurement and they were using it. The first known proof, okay, this is the first known proof of the theorem was in China. A text known as Shou Pi Suan Qing, meaning the arithmetic classic of gnomon and the circular paths of heaven. This is the thing written there. And it's also, they have given a name for it, which is Gogu theorem. They have given some kind of name for that. And I'm going to give you the theorem. The theorem is the proof is so simple, I'm not even trying to prove it. If any one of you have doubts, you can ask me at the end. So this is the proof of the theorem. So you can see the proof is there itself. This is the old thing which was there. You can see, if anyone has doubts, I will explain this thing. I'm giving this, only this picture is enough. This picture is enough to show the theorem was known to them and used, okay, explicitly. Okay, they are essentially using a plus b whole square minus 2ab is equal to a square plus b square, which is equal to c square. That's what they are using. Okay. Now the zero and place value. And I'm not going to dwell too much on this thing, but I'll go to the real achievements which were there in a few minutes. The claim of the discovery of zero and the place value in India is also disputed. While it's true that it explicitly stated in Indian number system, practice of such system was there in Greece as well as China. I'm going to give a couple of examples. On the walls of a tunnel in Samoa, the Greece, constructed in 500 BCE by two teams. So the tunnel is there, one team started here, one team started here, and they have engraved 10, 20, 30, 40, etc. in the engraved there to say how much they have done from this and this end, so that they meet exactly at the correct point. Okay, such a thing is there already in the track of the distance. Chinese number system also used powers of 10. They also use rods for counting, conceptually the same as Hindu Arabic system. Earliest Chinese system from oracle bones, they are called oracle bones, which are available now, used by royal declarations in 1500 BCE. Now I can go on talking about various things of this kind which people mention, even about plastic surgery issues, etc., which are very interesting. There is no doubt there was there. Even the number system was there. Pythagoras theorem was there. It was being used. It was being tried, okay, by things. But it was there in several civilizations. That's what we should not miss. But the golden era of our achievements started, I should say, around 400 AD, 400 Christian era, 400 CE. Around that time, there may be even earlier people. In fact, I'm trying to look at, because it is known in South India, between 0 to, that is, first 200 years, 200, 300 years, 0 to 200 years, there was a reasonably very good cultural life which was there. For example, if you have heard the literature Silappadigaram, it was turned around the time of 280, 208. Okay, that is the period for that. There is also Manimegal. There are several literature which is available to tell about how people lived. There was a cultural life which was there, and people were living, and constructions were there to make it a reasonable urban life, which was there in some places in this thing. And more work is being done now, whether that kind of urban life like Indus Valley civilization, etc., was there in South India, in places like Kiradi, etc., which is becoming more and more popular. People are getting to know about it, and more information may come later. But for the moment, the golden period of mathematics in our thing is something between 400 AD to 1400 AD. That is a time in which a lot of work was done. It was actually peak of the time where so much work was done because we could have beaten anyone on earth. There is absolutely no doubt about it. Aryabhatta was one of the propounders of this thing. So Aryabhatta lived around 400 Christian era. His great work he has himself written, and people call it Aryabhattiya. Okay, Aryabhattiya, it's a book. Okay, and few more books he had written. I'm not going to refer to all of them. It has 33 verses containing rules for arithmetic. It has geometry, first degree indeterminate equations. The second verse, for example, introduces decimal notation, which is what people use. Verse 4 and 5 talk about algorithms for square roots and cube roots, and triangle area, volume of pyramid, etc., are coming one after another in this book. In this book is outstandingly great book. I would like to call Aryabhatta as the Indian Galileo. Okay, why do I say that? I will come to that. In one of the methods, he uses pulverizer or Potaka method to solve the problems, equations which are there, which is very interesting. And very interestingly, he gave the sign trigonometry. He was interested in spherical geometry. He was interested in Earth's motion, astronomy, etc. And for that, you need sine functions. In those days, they called it Jia. Okay, I will use the current name, which is their sine functions. Between 0 and 180 degrees, he has given for all values from separated by 3 degrees 45 minutes. That is a thing which is there. For every value, he has given a number which is computed, etc., which was useful for him in not only astronomical thing, even the territorial calculations which were there, and also for people were needed for shipping, the people who go on the ships and boats and things like that. This kind of trigonometry was very useful for them, and it is important for them to. But most important contribution, we don't never realize, we don't ask that question, and also he missed the bus. This is the point which I wanted to tell. He said that Earth is spinning about an axis pointing to the pole star. That star which is there, which is not moving, the stars are going around. If you look at the early evening and then it goes around. And people were thinking earlier, because all over all the religious thoughts always had the God made earth, human beings are special, the whole thing was created for him or her. That is the idea. So everyone thought that we are stationary, okay, and the stars are moving around. He asked the question, if I see the star here at night 7 o'clock and after 12 o'clock it comes to this angle, how come it had so much fast? How is it so much speed, etc.? So he asked the question and he said it is like this thing, that it is not the stars are moving, then you are moving, okay, you are rotating, you are spinning, okay, you are spinning about the thing, and that's why the stars look like they move. And he gave the example of you are going in a boat or if you are going in a cart, horse ride, etc. Things try to look the other way. And very interesting, he was giving this thing and the spinning of the Earth's motion, spin of the thing, and he also related somewhat very closely. He said that seasons may be related to that. He made that remark. But he didn't ask one question. Why not only that star which you see at night? Why not you tell about the sun, which is also a star, which is so bright? At that time they never looked at it as a star. It's different. He said, why not say the same thing about the sun? He never asked that question. If he had asked that question, then he actually had the heliocentric theory. That is the point which is crucial. And this is the kind of a thing, etc. And he was very bold, extremely bold. He threw out the religious theory of eclipses being caused by snakes like Rahu and Ketu, and said Rahu and Ketu as shadow planets. It is the place where the Earth's orbit plane and Moon's plane, they meet at 2 points. The two circles meet at 2 points, and that is what is the thing. The Moon's orbit meets the plane of the thing at 2 points, and they are the Rahu and Ketu. And without that, you don't have the eclipses. Eclipses, if you want to understand, you have to understand these 2 points. And he said that this is the shadow planets which we should call. And he was ridiculed for this idea because people were fairly religious. Not only religious people, even the astronomers, astrologers, which was combined, he was ridiculed. And I will point out one more place where he was ridiculed explicitly by another astronomer. Okay, and because of that, he had to face problems. He didn't get job. He was like a postdoc going from one place to another place all over the earth, all over India. He was being shunted and looked for job in several kings, etc. Because he was a good astrologer also. He could predict very well, because if he can do this, at least he can tell when the eclipse will happen, when the somethings will happen, etc. And if people believed in one event like that, they can use it. There is no problem with that, because his predictions in terms of actual movement were much more accurate at that time. But unfortunately, this is what happened to him. He had to move around, and also he was lucky he didn't suffer like Bruno or Galileo. And I would like to call him as India's Galileo, because people later realized he was right. And so many people have written exposition of Aryabhatiya called Aryabhatiyam. And so many astronomers have written for next 800 years. People have written explicitly about him, etc. So this is the thing. The next person I'm going to talk about is Brahma Gupta. He lived after about 100 years later. He was the head of the observatory at Ujjain. He wrote Brahma Sputa Siddhartha on general maths. He defines mathematician as who knows 20 operations. Out of the most important is projections. People should know that when something is projected, something else is to be measured. And several procedures like cubing and integer, cube root, etc. are given in verses. And he was the first person to give a formula for cyclic quadrilateral, which is a well-known formula which students use even now. which is given here, where S is the semi-parameter. And the most important thing is, this is what I'm going to stress as his greatness. He gave an equation which is called nx square plus is equal to y square plus 1, or you can say nx square plus 1 is equal to y square, where n is an integer, x is an integer, y is an integer. It's a Diophantine equation. This equation was given by him. Remember this, I will come back to this again and again, at least once later. Okay, so this was the equation given by him, and unfortunately he was also a professional rivalry with Aryabhatta. So his remark about Aryabhatta is here. Aryabhatta knows nothing about mathematics, celestial sphere or time. I will not mention about his demerits. This is what he said. Explicitly he has written that also. So this is the kind of a thing Aryabhatta had to face. Not only from trivial people, he had to face from head of the observatory in Ujjain, who was also not bad. He was very good. His mathematics, he knows his thing. But unfortunately, that kind of situation always is there. Then next person I'm going to refer to is Bhaskara II. Bhaskara II was born in 1114 because he himself has written about it explicitly on which time, which date exactly he was born. That is the interesting thing about him. He was an outstanding mathematician, outstanding in the medieval period. He had written several books. I'm only referring to some of them. Siddhanta Shiromani, Leelavati, and Bijaganita, and I have written explicitly what they refer to. He solved quadratic equations, cubic equations, got negative and irrational, so irrationality he actually brought it. He estimated pi very accurately. His book, very interestingly, like our thing, gives the theory, for example, various things which are there, and also a log book, okay, my logarithmic table book, like our particle data book, where the numbers, etc., are explicitly given, and people who want to use for their artisan, craftsmen, etc., can use them. So this is the thing which were interesting about him. And this is a sample from his work, which I'm not going to read, if you can read things, but it's very interesting. The way Leelavati is written is poetic. It talks to the lady, your beautiful lady who are there. You go to that pond and you will find so many swans there. Some of them are flying away, some of them are here, etc., etc. This is the way each of the problem will be there. Very beautiful. Anyone who reads them will get interested in mathematics itself. That is the kind of way in which he was doing. Interestingly, he understood the difficulty of division by zero. If a quantity has zero as divisor, then there is no change when many others enter or leave, just as at the time of creation or destruction of many creatures, enter or come out of the infinite unchanging one, Vishnu. I hope our current friends don't take this as the origin of Big Bang theory. Okay. Both Brahma Gupta and Bhaskara leave number divided by 0 as 0 divided. They don't know the answer, so they have left it as 0 divided. Okay. And knowing the sign value for all from 0 to 180, and also he knew from sine A plus B formulas, cos A plus B formula, which he has written down, he wrote this formula. This formula is very interesting because he was giving a logarithmic table where calculations are done, and this is simply Newton-Raphson thing. He is giving the initial process of calculus. If x prime is slightly away from x, if x prime is away from x by a small amount, how much is the change? It is actually initial stages of calculus. He was giving the first steps towards calculus. And the most important remark which he made is, if the interior planets like Mercury, Venus, and Mars are considered as moons of sun, don't think about them as planets, okay, wandering planets. You just think about the moons of sun. Then finding that position becomes easy. Essentially, you add your position with respect to sun and the position of that thing with respect to the sun. Okay. Then from there, by the addition, by a simple manipulation, you will know where they are, and predicting them becomes very simple. Now, this is simply the heliocentric theory. At the end, what is it? These planets are going around the sun. That's what he wanted to say. And he also introduced a very beautiful concept, because the planet like Mars or Venus, They go and then make a small change, come back and then go. Because they are not, as seen by us, don't have uniform speed, uniform angular velocity. As seen by, if you are on sun, it will have uniform angular velocity. But as seen by us, it doesn't have. So the velocity changes with time. The time is not instantaneous, but over few days, etc. So introduce the concept of instantaneous speeds of planets for taking care of such an anomaly which is there and explaining many of these things. And which I think these are all very beautiful ideas which he had, which was seen at the time of 1100 AD or 1200 AD, which I was claiming that from 400 to 1400 kind of period, there were so many people in the whole of India, in many places, well versed in the works of geometry, trigonometry, algebra, etc., etc. Except there are some lacuna also, but these were there, and we should take care of that kind of. He was also the first to give the Indian proof of Pythagoras Theorem, I mentioned, right? He was the first person to give that. And also he solved, very interesting, I'm going to refer to this again. I mentioned about this problem, like nx square plus 1 is equal to y square. He solved that for one particular case, which is very interesting. And he solved it by a method called Chakravala method. Okay, people have written about it, I'll come to that later. He was also aware if a function is at a point where it is maximum, nothing changes when you move. Okay, it's actually f prime is equal to 0, which is called the Rolle's theorem. He was aware of it. So very interesting because of many of these things which he was able to do. Bhaskara too I consider as an extraordinary person at that time. Now last person which I'm going to refer to is Madhava and his school. This is probably the most famous school in mathematics, making several discoveries for at least 150 years. They started around 1300, it went up to 1450, okay? And there are several teachers, they were all from Kerala, okay? I'll tell you exactly where it is. So it's obvious there are several places where there are schools of this kind that are existing, and very interesting works have been done. The teachers were Madhavam, Parameshwaram, Damodara, Neelakantam, Jastadevam, Achyuta Pisarthi, Shankara Warrior, Citrabhanu, etc. There are many people also. They are only referred to more or less the directors of the institutions which are there. Okay, so the founder of the school, of course, like already here, founder of the school was Madhava. He lived from a place called Sangama Grama. The current name for that is Irinjalaguda. It's there in Kerala. Okay, Irinjalaguda, and there are people who claim that there were descendants of that kind of family even there. In fact, I did meet one of them. Well, I don't know how much authentic it is. Okay, there was a book which is called Yukti Bhasha. I'm going to jump into that. It was known, Madhava was known for his famous series, which is called, it was later people call it Leibniz series for pi by 4. Now, International Mathematical Society has recognized it was Madhava who discovered it first and call it as Madhava Leibniz series for pi by 4. Kerala school corrected several results, so Aryabhatta also has done mistakes. Okay, has done mistakes, and he corrected several mistakes of that and from the Aryabhattas. And he has also written treatises about Aryabhatiya, which is called Aryabhattiyam, actually a revised version of that. The treatise Yukti Bhasha, written by Jastadeva, is in Malayalam. It was written in Malayalam, not in Sanskrit. This made knowledge available to non-Brahminical sections without need of Sanskrit. The local language was being used at that time, which was very interesting. The crest jewel of Kerala school was infinite series. He was able to consider infinite series for trigonometric functions. So Neelakanta directly attributes to Madhava for giving accurate value of pi, accurate value, not approximation, as a series, infinite series. The rule for circumference C in terms of diameter D as given by this formula which is there. He had also written down this formula for theta is equal to tan theta minus tan theta cubed. These formulas were used nowadays in Maclaurin series, various series which are there in calculus books. They were given by Madhava in 1350. That's a very remarkable achievement at that time. Okay, I'm going to change gear because I mentioned about this problem which is nx square plus 1 is equal to y square. Slight change in gear, which is not the thing. Ramanujan was in Cambridge and he had a great friend, who was well-known person, P.C. Malanavis, was the founder of ISI. One morning, and in fact he was a great moral support for him because without him, there is no other Indian to whom he could talk about his problems. That's a different story by itself. See, Malanavis came to him on one Sunday morning with a problem which was seen in Strand magazine. It is referred to in this book, Robert Kunigel's book refers to this problem. There is a street with more than 50 houses and my friend is in some house in between. The sum of the numbers before and after are equal. The sum of numbers before is equal to the sum of numbers after. For example, if there are 8 houses, if the friend is in the 6th house, 1 to 5 will add up to 15, 7 plus 8 is also 15, these two are equal. This is the example for that. But unfortunately, he has given the condition, the number of houses more than 50. So this cannot be used. Okay. So Malanavis claimed, very intelligent, there is no doubt. He struggled and struggled for a couple of hours and solved it. And after solving it, he gave the answer as 289 and 204. This is the answer he gave. And Ramanujan, according to Kunigel's book, he was making tea, okay, unlike coffee, like a Kumbhakonam Brahman, okay, he was making tea, and he said that after that, he said, no, that's not the only solution. And he gave some 4 or 5 solutions, one after another. And Malanavis was shocked. How did you find it? I took 2 hours to get this solution. You are giving me 4 more solutions without even looking at the problem more than 2-3 minutes, 4 minutes. Okay, how is it possible? And he gives the answer, and the answer is very brilliant. It is again mentioned in Kunigel's book. Ramanujan explained how he got there. There must be a continued fraction, which when truncated gives numerator and denominator related to our solution. This is a school level problem. We can do it. It's not very difficult. Okay, you say n and m are the 2 numbers, houses, etc. You know how to add 1 to m, and then how to add m plus 1 to m, etc. and then equate it. So you say x is 2n plus 1, y is 2m, and you get the same equation, which is 2x square plus 1 is equal to y square. This is what Brahma Gupta gave, but unfortunately modern literature in mathematics called it as Pell equation, because Pell gave in 1700 and Brahma Gupta gave this kind of equation at least 1000 years before. Okay, this is what happened. Actually, this kind of equation should be called Brahma Gupta equation, and the solution for that Ramanujan obtained very, very interestingly. He is a physicist, my opinion. He dropped that 1 because if x and y are large, let me drop 1. Then it says 2x square is equal to y square. So y by x is square root of 2. So let me write the continued fraction for square root of 2. And the square root for 2 is what I have written down here. You truncate it. Because you have dropped that 1, you approximated it. Now bring it back, essentially truncate it. When you truncate it, you are going to get the numerator and denominator. And those numerator and denominator are exactly the numbers which you wanted. So the numbers are there, including the work by Malanavis is there already. Okay, that 577 by 408 is the solution which was given by Malanavis, because 408 is 2 into 204. Okay, that is the solution which he gave. But only thing is he was able to give immediately several solutions, and this is how he obtained. Okay, very interesting that this is what happened. Now, if he had the equation, this is where the punchline is coming. If he had the equation 61x square plus 1 is equal to y square, okay, if he had that equation, not 2x square plus 1, 61x square plus 1 is equal to y square, even Ramanujan would have found it difficult to solve. So, okay, it is a very difficult thing. Such a problem was posed by Brahma Gupta himself. He has written 61x square plus 1 is equal to y square. Solve it. Nobody solved for 400 years. Like our Fermat's last theorem, nobody solved for 400, 500 years. It was Bhaskara who solved it. Bhaskara too who solved it. I'll come to that. How did this problem was given by Fermat, Euler, Lagrange, various giants of mathematicians in 17th and 18th centuries, and they were also given that problem. Some of them solved it, but after many days of working, they solved it. Why is it difficult to solve this equation? Because what is it if you will try by trial and error, let me put 1, 2, 3, 4, 5, etc., etc. But the first solution for this is what is written here. Something like an 8-digit number and 10-digit number. Now, even if you use your calculator to verify, you cannot do that from this kind of a calculator. You need a computer to verify it. Bhaskara got the above solution 500 years before these people by a method which is called Chakravarti method, which in my opinion is outstanding. What he did was, he went from x, y and n. There are 3 numbers, x, y and n. X, y to x prime, y prime, by what now I will call it as SL2Z transformation, a group theory. He made a transformation, x, y to x prime, y prime, by SL2Z transformation. He converted the problem some 3 or 4 times, and got a problem where it looks exactly identical, x prime square, some n prime x prime square plus 1 is equal to y prime square, which is easy now because the n prime might be a simpler number. So solved that problem, went back and got the full solution for it. This is an outstanding method, algorithm which he developed at least 500 years before this, which is very, in my opinion, outstanding. And this happened because one mathematician friend of mine, when I went to some place, he told me this equation he was interested, not 61x square, he wanted an x square plus 1 is equal to y square. As if you know group theory, if you know SU3 Lie algebra, it is specified. This x and y being integer is essentially says there are lattice points. Okay, so you can find the representations which are from there. If you tell me what is that x, y, okay, 2 numbers. If you tell that in SU3, you can get it. He wanted to find all the representations which are lying on a hyperbola of that kind of a thing, and he wanted my answer for that. I told him it was done by Brahma Gupta and Bhaskara earlier. You can use it. That's what happened. Okay. Now I'm going the next 10 minutes. Can I take 10 minutes? Is that okay? Looking for answers. There are many questions. So far I have finished some outstanding people. Now I'm going to unsolved problems. I'm going to look specifically briefly. So first, there are 2 things. I'm going to talk about 2 things. First is about what is called 1054 AD Crab Nebula. And second thing is about something about solar temples. They are my favorite. So I lived in those places. This is my favorite places. Okay, so this is the thing. So what happened? In 1054 Christian era, or AD in those days people will call, there was a major astronomical event, a supernova explosion, seen as a guest star, appeared in Taurus constellation. It was so bright, it was visible for 21 days in daylight. In sun's light, it was visible for people for 21 days continuously, and it was visible at night for nearly a year. For 1 year, it was visible at night. It was so bright. It was even expanded further, because after all, supernova expands after that. After that 1054, SN 1054, the expansion of the whole thing takes place, astronomical event. It has become now about 11 light years. Okay, the distance is huge, 11 light years, and it is visible even now in powerful telescopes, Hubble telescopes, etc. This was recorded in several civilizations, but the Hubble telescope picture is here. This is the Crab Nebula, SN 1054 AD. Okay, this is the name for it. But this event was visible on Earth in those days on 4th July. Very interestingly, people now can go back and pinpoint when it happened. 4th July 1054 AD. And it was there visible in daylight for 20 days, and night light for nearly a year. This is the kind of a thing which happened because of this thing. So now Chinese astronomers in Song Dynasty have recorded this star-like object which was 7 times brighter than the Venus at that time on 4th July 1054. It was visible for 2 years, that's what till faded. It was also mentioned in a diary of a poet in Japan. It was mentioned by a doctor in Iraq who associated epidemic around that time with the appearance of this. People always associate some kind of bad events, comets bring bad things, etc. Such a thing. In 1955, a researcher associated with Mount Wilson Palomar observatories presented 2 pictures for evidence that some Indians in North America have seen it, because he saw a painting on a rock and other chiseled image on a rock of a crescent moon and a round object. This is exactly what was written in Chinese thing also. The crescent moon was there, and by the side there was a dot, this star-like object was there, visible, etc. So people could associate, and the timing, etc. matched. So there was some evidence for this. So many evidences are there from different places. Okay. Now the question is there any record of this cataclysmic event anywhere in India? I told you between 400 to 1400, India was leading person in mathematics, geometry, trigonometry, and astronomy. Okay, and people are interested in looking at that. And is there any evidence of anywhere it is recorded? Professor John Narlikar considered this question, it's a very important question, and looked for records in literature, because at least in literature people would have referred somewhere, etc. With Professor Saroja Bhatin, Sanskrit and Prakrit language, Pune University person. It was done under INSA project. They collected contemporary and not only literature around 1050 AD, for another 100 years, any literature. People would have, folklore will be there, somebody talked about it. So they were looking for that, and unfortunately, they surveyed materials from Pune, Bombay, even Chennai. Their collection was enormous, but they focused mainly on Sanskrit. Our searches did not lead to any convincing result. A detailed list of our notes and searches are available as report to INSA. We encourage people to explore this further. Okay, so obviously they have limited this to Sanskrit literature, if probably some Tamil literature. The kind of example I was looking for was around the time Kambaramayana was written down, around 1100 AD. This is the time when Kambaramayana was written, and several other literature was there. Is there any place where Kambar or somebody remarked that there's a star in the daylight or something like that, which is thing? Then one can look for whether it tallies with many of the things which are there. Unfortunately, do not get it. I had a friend by name Professor Ratnasri. She was the director of Nehru Planetarium. Unfortunately, she passed away last year during COVID. Okay, due to COVID. And she also had a speculation. The speculation was interesting. The cosmic dance, because supernova is a cosmic dance, okay? It's a huge, violent event. In India, cosmic dance is represented by Shiva dancing Rudra Dandava. Okay? So she was trying, is Nataraja, which is popular in South India, is it a representation of this event? For example, the Chidambaram temple was built around 1300 or so. Is it representing that kind of a approach to this problem? Unfortunately, it is not satisfactory. Such a dance represents victory dance in the Chola period, soldiers, known even before 900 AD. It is, people used to have, and there are several temples where this kind of dance is presented. Okay, it's Nataraja dance became popular, the dance thing, but it was known earlier also. Anyhow, an attempt was made to superpose the position of the stars around Taurus with Nataraja and try to see a link. Okay, I will show that picture, which is not convincing. So it was a speculation by her, and nobody is convinced. And also you can say there is this appearance of Jyoti in the Sabarimala. A culture started around that time. This appearance, because the star appearing, the event appearing is also somewhat matching, but I don't have an answer for this. This is the picture of from her paper, where they are trying to match the star's position with the Nataraja Dance positions, and it doesn't look convincing to anything. So this is an outstanding problem even now. If people can do more work on literature other than Sanskrit, or even in Sanskrit, they may find some evidence that is referred to in other. It's a question which is unanswered even now. The next question is my favorite thing. Chola kingdom from 900 to 1300 AD. It is also matching with several advances, flourishing culture, etc. in several places, including South India. Okay, sorry. Many powerful kings, Rajaraja, Rajendran, Klothingan was the one who built the Chidambaram temple, and many others, spread over large region of South India, and they even went up to Thailand. They had a fantastic shipbuilding culture. They could go easily, and that required lot of, as I told you, lot of improvements in their understanding of mathematics, trigonometry, and astronomy, etc. Otherwise, how do you go in the sea? You will be lost completely. And Thailand, Cambodia, in fact, Angkor Wat was built by Chola emperors. Okay, so people associated with them. Great period of great surplus, and everything was due to one thing. That is the Kaveri river flowing from Karnataka to Tamil Nadu. It was so much water. People were doing harvest 3 times or 4 times a year, and the wealth was enormous. And also they went and occupied and looted from other places, brought wealth, etc. here, and there was so much wealth available in these regions. And there was a culture of development which is always associated with that which is happening. And the temples were interesting. Bragadis, I am going to refer to only few of them. Bragadiswara temple in Tanjore, Gangagonda Solapuram, which I mentioned in the first page. Okay, that temple is from there. And there is another temple called Narasuram near Kumbakonam. These are all temples which are very close to the places I have moved. And if you see, this area is full of temples from this end to that end. Even in Kumbakonam kind of place where I live, the number of temples is more than the population at that time. So many temples, and all of them have a similar structure. The Gopuram will be there, Karmagara will be there, etc. was there. Very interesting. Okay, so this is your Brahadiswara temple in Tanjavur. Okay, very interesting place. There is a temple for each one of the planets in this region. This region has one temple for Jupiter, one for Agni, Saturn, one for Rahu, Ketu, everything. Is there one temple is there in this region. In fact, now they have a tourism for visiting all these temples also, which is a religious tourism which is happening. Temple building had become like an industry with levels of standardization and uniformity. The question always rises, who built this? Okay, this is the question people will ask, because they are very beautiful, and if you have visited, you will be impressed not only by the structure. If you look into the minor details of small sculptures which are there, some of them are so beautiful. In fact, they are a precursor to Escher kind of painting. In sculpture, there will be sub-sculpture which if you cover one part, it will look like one. If you cover another part, it will look like elephant. If you cover this, it will look like bull, etc. That kind of thing was there, and very beautiful thing, even in minute details which are there. And you can ask the question, who built this? The kings only funded. Okay, kings only funded. They gave the money. There is no doubt. Was there a school, university culture on science and technology, of architecture, which is related by all these subjects which are required? Without that, you don't construct that kind of a building without active involvement of 30, 40 engineers, let me call them as engineers, who are involved in planning details, and also they need specially sculptors who will do the thing at different places. Was there? Answer is, there seemed to be that kind of a culture. There is a literary book which is called Sivaka Sindhamani, which relates, is mentioned. There was a culture of actually people going to school, people going to college, kind of things actually referred in that kind of a thing. So they're wrong, but only thing is we don't have any evidence except this kind of a literary remark, but explicitly written down what is there. And is there well-known master craftsmen? Is there any attempt to? So attempts to get answers are incomplete. So I came across two names. It is not as though I was not successful. I came across two names. Claimed master architect is Kunjaramallan Rajarajan Perumtachan and Nitta Vino the Perumtachan. Okay, Tachan is actually carpenter. Okay, Perumtachan is big carpenter, somebody the higher level, senior professor. Okay, that kind of a thing which is there. Okay, but these are names which are mentioned and it is not yet confirmed what is the role, where they lived, etc. And one more person I came across was Suryadeva Yajwa. He actually lived, that person actually lived in Gangaikonda Solapuram around this time, 1100 AD. And he was a brilliant mathematician of the same caliber, like probably trained from various sources of the Ujjain and other places. And he lived around 1100 AD. He had also written a treatise on Aryabhatta, Aryabhattiyam material, explaining various things which are there, adding his own notes, extra notes which he has added, and he's also lived. So it is not clear whether there is an institution in these areas who were able to do all these works, and do we have more names? We don't know. I was trying to look at various places like Saraswati Mahal and other places in Tanjavur. I have only limited options, so probably later I will try to do more. So my sources are Narlikar, which is a spelling mistake, Scientific Edge, Penguin Publishers, Meera Nanda, Sovereign Science, Joseph Needham, he talks about Chinese science, Astronomy in India, Rajesh Kochar and Jayant Narlikar, Kim Plofker, Mathematics in India, Ratna Street, this is the material which I pointed out, and several other sources. I could not write all of them. P.P. Divakaran, who used to visit, he has a book on mathematics in India, ancient India, and very interesting. So this is the thing. Sorry. So I will stop here, and I hope I have taken correct amount of time. Is that okay or more? Thank you.
Thank you very much, Govindarajan, for a very interesting and very thought-provoking set of slides. The floor is open for questions. First, starting questions from the audience, live audience.
Do you have any speculation why was that supernova event not recorded?
More than my speculation, Narlikar himself has speculation. Okay. He relates it to too much religiosity. They were focusing on various other issues of that kind. Not even people who are well versed in the mathematics and other things, they were also focused on such things. So he himself says that that could be one of the reasons. There is no other speculation, nothing. But it may become available. It is not as though thing. But only thing is our nature of a thing, we always look for only this thing. But only now, other languages, like for example, fantastic culture was there in Karnataka, in that area, in 1300, 1200 AD, etc., even earlier. So there may be other literature which tells you something, and we may find something. It is not clear yet.
Thank you.
Comment of yours on who built these temples.
Yes.
What triggered you to actually look for this information?
Actually, I will tell you exactly what made me. Unfortunately, this is also partly political question. So there was this famous Adams Bridge next to Rameswaram, etc., which is connecting India and Sri Lanka, which is essentially a natural formation where if you can swim, well, there are places where, for example, there used to be a boat mail which went up to Dhanushkodi, and from there you can cross. If you can swim a little bit, within few kilometers you will reach Sri Lanka. So Adams Bridge was there, and people always associate that Adams Bridge with Ramsey, this built thing, etc. And there was a big controversy at that time. Okay, big controversy at that time. And one political person from these areas who was committed to making that kind of a new arrangement for this thing, he asked the question when somebody said Ram built it. Okay, that is the answer which is given. Raman, Hanuman, etc. built it. He asked the question, which engineering college did he go? Okay, this is a question actually asked in the public domain. Then I have been always told Rajaraja built Pragadisura, Rajendra Solan built Gangaikonda Sorapuram. We can ask the same question too. Who built it? Obviously, the person requires this kind of structure cannot be created by some low level. The low level people will, with the initial stages, mason, etc., will do smaller temples, etc. There should be a large scale structure of people involved, some 30 people, 20 people, etc. Because this thing took nearly 10 years to build it, right? And I didn't show it, probably I can show it to you. The top portion which is there is a huge stone and single stone, okay? Single stone of 1 ton. The weight is 1 ton. The question which is asked is, how did they take it there? Okay, how did they take it there? The answer is no, because there is a place near Tanjavur where the temple is there, about 5 kilometers away. From the starting point, they built an inclined plane. They really built an inclined plane with several elephants and other things pushing this rock, one single rock, taking it to the top. That is the level of work which was done. So even to say how far you have to go to take it with this kind of a thing requires some calculation, some understanding of various things which are there. So there is a name for the place where the starting point is there. That name of the village is also there. So this is the kind of a question which people can ask. And it is not usually many places they write down in the somewhere like our foundation stone, etc. They write under the orders of the thing, so and so built it, etc. Unfortunately, there is nothing available here. Okay. For example, Taj Mahal, we know the person who built it. Because, of course, Shah Jahan paid the money, okay, and he brought some architect from Persia, and he had several teams of people generated, etc., and built it. Well, there is a rumor or folklore which goes, after he built it, after the whole thing was over, he cut his fingers, Shah Jahan, so that he will not do it again. So he wanted to be unique. But this may be or may not be true, but this is the kind of a thing, but we know who did it. But it's only 400 years back. This is 8,000 years back. And we, for example, we can ask the same thing about Kanchipuram temples, etc. The number of temples in South India of this variety is enormous. It's very interesting, large number. So large number of that kind of a thing requires, it's a standardized activity, almost standardized activity of this structure. Okay, small chieftains will build small temples. Big kings like Rajarajan will build big. In fact, if you look into the two temples, one is Rajarajan's temple, Bragadiswara, and this thing, they look identical structures. And when his son built in Gangaikonda Sorapuram, Rajendra Solan, he was told he should not build it, more height should not be more than his father's. So Gangaikonda Sorapuram has less height. But he wanted to be unique. So uniqueness, that pyramid structure which is there, instead of making it as a straight line, he made it in a curved line. If you actually see it, you will see it is actually a parabolic thing which is there. I don't know whether you can see it. Okay, let me see. It is the first picture. Well, it is there in my poster also. So it has a parabolic structure on the corner which will be there. Okay. Unfortunately, the light, whenever we take some time to come back. Okay, it's okay. So that is the way he tried to be unique.
Thanks, Professor Govindarajan. If there are no more questions from the audience, so we will close the session now. Thank you again, Professor Govindarajan, for a very interesting talk.